Good morning. My name is Relebohile Lefojane from the Central University of Technology in South Africa. I am under the supervision of Professor Mamello Sohwater from the University of the Free State in South Africa still. So this morning I will be presenting on my study, which I've been on for a while now, but I'm still continuing on it. The title of my study is Cadmium Oxide, Cadmium Carbonate Nanocomposite Physical Properties and Cytotoxicity Against Selected Breast Cancer Cell Lines. In 2020 alone, WHO reported 2.3 million new breast cancer cases, of which 685,000 resulted in death. Breast cancer has different types, which are mainly determined by the presence or absence of receptors known as estrogen receptor, progesterone receptor, and human epidermal receptor. In the tumors where these receptors are absent, that's what we call triple negative breast cancer. And unfortunately, triple negative breast cancer is the one that is associated with being greatly invasive, highly aggressive, and most likely to recur and metastasize. So the question is, why is this the case for triple negative breast cancer? One of the reasons is that due to the lack of the receptors, triple negative breast cancer alters drug efficacy as treatment mechanisms operate effectively in the presence of receptors. And secondly, it's unresponsive to available treatment, such as your hormonal treatment. With regards to chemotherapy, it does respond, but the downside of it is that chemotherapeutic agents just not destroy or damage the cancerous cells, but they also damage the non-cancerous cells, therefore causing strain on organs and tissues, and therefore resulting in high mortality rate. According to statistics, less than 30% of women diagnosed with triple negative breast cancer will live for a period of 5 years. The other issue is that there is poor bioaccessibility of these drugs to tumor tissues, and therefore requires high doses that lead to elevated toxicity in normal cells. This, to me, says that there is an urgency and a need to continue embarking on alternative triple negative breast cancer treatment that is highly targeted and it induces less toxicity on cells. Could it be that the nanoparticles, which have really gained so much interest from researchers, could they be the alternative treatment lead for triple negative breast cancer due to their unique physical, chemical, and biological properties, which according to literature have seemed to be efficient anti-cancer agents? Again, according to literature, cadmium oxide, cadmium carbonate nanocomposite have shown to induce apoptosis in cancer cells, which also makes them vital for targeting cancer cells. But is this really the case? So the study aims to test the hypothesis that cadmium oxide, cadmium carbonate nanocomposite have decreased cytotoxicity on normal cells but instead they are selective towards cancerous cells. And this, of course, will be done by firstly synthesizing the nanoparticles using a green synthesis technique, which is innovative in the sense that when you use plants, they are more eco-friendly, they are cheaper, and they are easily accessible. On top of that, plants have phytochemical constituents, of which some of them have anti-cancerous activity. The objectives that will be met by this study, or rather that have been met by this study, include synthesizing the nanoparticles using the green synthesis technique, characterizing them, and screening the nanoparticles for cell growth inhibition. Okay, the methods that were utilized, of course, it's the green synthesis, but prior to green synthesis, extraction is mandatory. In this study, water was used as a solvent, and the plant material used is Cynadenium cappular leaves, which were found in Limpopo in South Africa. And the reason Cynadenium cappular was used is because historically it was used as an anti-cancer remedy or anti-cancer agent. When extraction process is complete, the extract was then mixed with cadmium metal solution or cadmium nitrate to successfully synthesize the nanoparticles. In as much as the procedure was followed, we need to ensure that indeed the nanoparticles have been synthesized, and that is where now the characterization techniques come into play. XRD or X-ray diffraction was used for crystallographic analysis, and for morphological analysis, both transmission electron microscopy and scanning electron microscopy were utilized. Chemical analysis was carried out using X-ray photoelectron spectroscopy, whilst absorbance spectra was conducted using ultraviolet visible spectroscopy, and the Fourier transform infrared was used for organic and inorganic materials analysis. For screening of the inhibitory activity of the nanoparticles, the cell culture technique was employed, of which the nanoparticles that were annealed and unannealed were used, and the cell lines that have been used include the MCF7, which is the normal breast cancer cell line, the MDMB231, which is a triple negative breast cancer cell line, and the varicose line, which is a kidney cell line. And in this case, it is the non-cancerous cell line, which will be very helpful in calculating the selective index of the nanoparticles or the cadmium oxide, cadmium carbonate nanoparticles. So we want to find out, can cadmium oxide, cadmium carbonate nanocomposite really select the cancerous cells over non-cancerous cells? Now it's time to find out. But before we get to that part, we will firstly discuss the results from characterization. Whilst heating the nanoparticles in the oven after synthesis, in figure 1, we observe the crystallinity. Yes, and this interestingly is also confirmed by the X-ray diffraction, whereby the cadmium oxide nanoparticles were found to have crystallized in the face-centered cubic phase, whilst the cadmium carbonate crystallized in the rhombohedral phase. So this shows crystallinity. And of course, the XRD has confirmed the formation of cadmium oxide, cadmium carbonate, nanocomposite. With the morphological analysis, the scanning electron microscopy, which is often used to analyze the external structure of the nanoparticles, showed or rather depicted the morphology with agglomerated spheres with surface-bound rod-like structures. Also, the DS spectra was carried out showing different elements, and interestingly, cadmium and oxygen were some of the elements found on the surface, and also your potassium, your chlorine, which I believe this associated more with the phytochemical constituents of the plant extract from Cynodanium capillare. Figure 2A and B show morphology results from transmission electron microscopy. In figure 2A, it's annealed nanoparticles. Figure 2B, it's unannealed nanoparticles. This show an agglomeration of non-uniform shapes. With regards to the absorbance spectra, which was carried out by UV-Vis, the absorbance peak was observed at 279 nanometers, and this can be ascribed to water in which particles of the cadmium oxide, cadmium carbonate composite were dispersed. And with chemical analysis, which was done using XPS, we observed different peaks depicting different elements, of which also show the presence of cadmium oxide, cadmium carbonate, and some elements from plants such as your chlorine, such as your potassium as well. And this still continue to show that indeed we have synthesized cadmium oxide, cadmium carbonate, nanocomposite. And lastly, regarding characterization, we will discuss the organic and inorganic analysis, which was carried out by FTIR. This showed two fingerprint regions, with the first region lying from between 400 to 1,000 cubic centimeter, and also depicting cadmium oxide. The second fingerprint region lies from 1,422 to 2,490, also depicting cadmium carbonate nanoparticles. So this is a continuous confirmation of the successful synthesis of the nanoparticles. And now, the most interesting part of the study, what we have been waiting for. Do cadmium oxide, cadmium carbonate nanocomposite show selectivity towards cancerous cells, or rather towards triple negative breast cancer cells in comparison to normal cells? So from the cell culture experiments, we got the results which showed that indeed MCF7 cell line, which was used together with the other cell lines, the activity of the nanoparticles on MCF7 cell lines showed the selective index of 90.04. And these are, of course, the results of the annealed nanoparticles. So this shows that annealed cadmium oxide nanoparticles showed selectivity towards MCF7 in comparison to Vero, which is a non-cancerous cell line. So that is exciting to observe. And secondly, the MDA MP231 cadmium oxide nanoparticles, also both annealed and unannealed, showed the selective index value of both 15.5, which is relatively a good selectivity index. And also this shows that indeed cadmium oxide, cadmium carbonate, nanocomposite are selective towards breast cancer cells. However, I would recommend that moving forward, more cytotoxicity tests on normal breast cells should be performed to inform selection. And in conclusion, the study proved the hypothesis that cadmium oxide, cadmium carbonate, nanocomposite show decreased cytotoxicity to the cells as they focus or rather they target the cancerous cells. And what's also interesting is that cadmium oxide, cadmium carbonate, nanoparticles or nanocomposite is not limited to the mode of receptor binding, since triple negative breast cancer has no receptors. Thank you.